Okay, let's talk about chat. We're going to start chapter 3 today. We're going to talk, and this is a very vital, important chapter. We're through all the logic and stuff. We're through all the wording. Now we're applying some geometry. We're going to be dealing with parallel lines throughout this. Now, right now, we're just going to talk about relationships, and I'm going to tell you this right now. The relationship we're going to talk about in this section, you have to learn them because they are so vital, not just to this section, but not only to just this chapter, but this entire course, first semester and second semester. So it's key that you must learn these relationships. All right, first of all, let's look at the homework quiz. Well, actually, it's the warm up. I should title it warm up. So, okay. And it says we are given that the angle one and angle two are complementary, or sorry, angle one and angle three are complementary. Angle two and angle three are also complementary. So we want to prove that angle one is congruent to angle two. So this is actually one of the theorems that we have here. I can't remember exactly which one it is, but it is what it is. So you can look. We'll talk about that later. All right. Now, in our given statement, our given is angle one and angle two, or sorry, angle three are complementary. Angle two and angle three are also complementary. And that's the given. Normally I don't take up that much space, but still. All right. Now, since they're complementary, we know that the measure of angle one plus the measure of angle three equals 90 degrees. Well, we also know that the measure of angle two plus the measure of angle three equals 90 degrees. And that is by definition of complementary. I may have put the hyphen in the wrong place, but I apologize. So anyway, all right. So we know that these two statements are true since these two pairs of these two angles are complementary and those two angles are complementary. We know that they add up to 90 degrees. Well, here's the thing. Since they both add up to 90 degrees, then that means that both of these components equal one another. So the measure of angle one plus the measure of angle three equals the measure of angle two plus the measure of angle three. And that is by you can either say transitive property or substitution property. I'm going to write them both. Transitive or substitution. Either one. All right. Excuse me. Now, we're trying to prove that angle one is congruent to angle two, but let's look and see what they have in common. They both have angle three. Since they both have angle three, I can subtract angle three from both the left and the right. And when I do that, and since I'm subtracting by angle three on both the left and the right, that is by SPOE, subtraction property of equality, because I'm subtracting on both the left and the right. And then, when I get rid of those, I have the measure of angle one equals the measure of angle two, and that's by simplifying. Now, we're not quite done yet. We still got to prove that angle one is congruent to angle two, but we're given that their measures are equal. So now we got to state that they're congruent. And why are they congruent? That would be by the definition of congruence. All right, now that's that. So we have proven what we're trying to prove, so we're done. All right. Now, that's the warm-up. It says homework quiz 3-1. That actually should be the warm. It should be titled the warm-up. So, oops. All right. Okay. Now today we'll be able to determine the relationship between each of the given angles given the information. All right, first thing you need to know is the transversal. The transversal is a line that intersects coplanar lines at two distinct points. So exactly, it intersects these two lines right here at this point. I'm gonna right there. I highlighted those in blue. So you see when yellow and blue, it makes green, but those are the two distinct points. All right, so that's the transversal line. And it intersects this line right here and that line right there. And as you know, it forms 8 angles. 8 angles formed. All right. Now, let's talk about the relationship between those angles. And there's several of them. And I'm just going to tell you this right now. You have to learn these relationships, starting with alternate interior angles. Alternate interior angles, we have two pairs. We have angle 2 and angle 6, which I'm going to highlight in blue, angle 3 and angle 7. Now, the reason why they're alternate interior is because if you look, they're inside the two lines. That gets interior. And then alternate sides of the transversal. Let me state that again. Alternate because they're on opposite sides of the transversal, which is this line right there. And interior because they're inside these two lines. That's why they're called alternate interior angles. So that's alternate interior angles. You can rewind this and watch it again if you need to. That's the good thing about videoing. All right. Now, next we have alternate exterior. So alternate, just like before, opposite sides of the transversal, outside, exterior, outside the two lines. So, angle 1 and angle 5. I'm highlighting those in blue. Angle 8 and angle 4. I'm highlighting those in green. So, alternate, opposite sides of the transversal, exterior, outside the two lines. And these are the two lines, of course, that I'm talking about. All right. Now, these next angles, sometimes they're called consecutive interior angles, and sometimes they're called same side interiors. So I'm going to write both down. Same side interior I'm going to highlight that in yellow. I've taught out of books that call them same side, and I've taught out of books that call them consecutive. And I honestly can't remember, so I'm going to use both. So when we get to that point, and most likely it's going to be same side interior, but I want you to know that they're both. Okay, so same side interior. Now it's just like it sounds. It's two angles, interior, same side of the transversal. So if you look, same side or consecutive interior, same side of the transversal, inside the two lines. So alternate interior, I'm going back for a moment. Alternate interior, opposite sides of the transversal, inside the two lines. Alternate exterior, opposite sides of the transversal, outside the two lines. All right, and then same side interior, same side of the transversal, inside the two lines. All right, so those are three of the four main relationships we're going to talk about in this section. All right, now the fourth and final one we're going to talk about is what's called corresponding angles. Corresponding angles right here. For example, I have angle 2 and I have angle 4. If you look of their intersection, they're both on the top right. Got my directions wrong. I'm a math teacher. My directions get wrong at times. Oops. Didn't think you'd mind, but hey, got you thinking. That's a good thing. Thinking is good. All right. I don't get to talk about that much in class because I don't see you all in class. I see you all once a week. So anyway, angle 3 and angle 1. This time top left. That time top left. I got the directions right this time. 8 and 6. Oh, that was a mess up. Oops. I got so highlight happy I forgot to do that. So and then 5 and 7, bottom right. Bottom right. There we go. Back to that. Okay, I'm just kind of playing around with that a little bit. So, all right. For the next bit, I think we can get through one more thing. I want to remind you real quick, and then I'll stop this, and we'll do the last part of this because I want to spend a little bit of time on the next part. Okay. So, parallel lines. Remember, are coplanar lines that do not intersect, and parallel planes are planes that do not intersect. Skew lines are non-coplanar lines, therefore they are neither parallel nor intersecting. So, for example, if I have all segments skewed to BC, so I'm going to look at that real quick. BC is right there. I'm going to highlight BC in yellow. So all the segments that are skewed with BC would be the following. AF, DE, GF, and HE. Because they're never going to touch BC, and they're never going to be parallel with it either. So, all right, so that's that one. And I'm going to pause this for the moment because I want to spend a little bit more time on this one. And then I'm going to